Hey everyone, and welcome back to G Fun Facts Online. Today, we're diving into a piece of tech that's straight out of a sci-fi movie, but it's very real and getting more impressive every day. I am talking about augmented reality, or AR, and specifically, the magic that makes those sleek AR glasses possible, waveguide technology. You know, AR is all about overlaying digital information onto our real world, and waveguides are the unsung heroes making that happen. We're talking about glasses that could one day be as common as your smartphone, but to get there, they need to be light, comfortable, and visually stunning. So how do we achieve that? Let's find out. So what exactly is a waveguide, and why is it so crucial for AR? Think of waveguides as the optical backbone of modern AR glasses. They're the super smart surfaces that direct those virtual images right into your eyes, all while letting you see the world around you. The cool part? They manage this without needing bulky setups. Instead of external mirrors or clunky components, waveguides cleverly guide light within the lens itself. This is key to making AR glasses as slim and light as the regular eyeglasses you might be wearing right now. Now, for a tiny bit of physics, don't worry, it'll keep it simple. It works a bit like this. A tiny projector, a microprojector, beams an image into the lens. This light then bounces along inside the lens, thanks to something called total internal reflection. Basically, the light gets trapped and guided perfectly. Finally, it's directed precisely out of the lens and towards your pupil. To get the light to behave just so, engineers use nanotechnology, borrowing tricks from the semiconductor industry to fine-tune everything for the best clarity and brightness. There are a couple of main types, like diffractive and reflective waveguides, but both rely on this clever light-guiding trick. Okay, so why all the fuss about waveguides? Well, the benefits are pretty game-changing for AR. First off, as we said, they make AR glasses compact and lightweight. Because the whole optical system is timing times the lens, we can finally ditch those big, awkward headsets. Imagine AR glasses looking and feeling just like your favorite pair of designer sunglasses. Second, they offer fantastic optical see-through capability. This means you can see those virtual images, like a map or a notification, overlaid onto your real surroundings without losing touch with what's actually in front of you. Super important for staying aware. Third, the image quality can be amazing, sharp, vibrant, and high resolution. And finally, engineers are constantly pushing for a wider field of view, or FOV. A wider FOV means you see more of the virtual world, making the whole experience feel much more natural and immersive. Special materials with a high refractive index, meaning they bend light more effectively, are helping to make this happen. Now this is where things get really exciting. The world of waveguide technology is moving fast, and there are some incredible breakthroughs happening. One of the most significant recent advancements comes from researchers at Postech, the Pohang University of Science and Technology. They've developed something called a single-layer achromatic metagrating waveguide. Whoa, that's a mouthful. Let me break it down. Traditionally, to show full-color images, AR waveguides needed multiple layers of glass stacked together. One for red light, one for green, and one for blue. This, as you can imagine, added to the bulk and weight. But this new Postech tech manages to do it all in a single, ultra-thin layer of glass. How? They use an array of incredibly tiny silicon nitride pillars. We're talking nanoscale here. The shape and arrangement of these pillars are so precisely designed using complex algorithms that they can control how light bends for all colors of the visible spectrum, all at once. This single layer, which they've shown can be just 500 micrometers thick, that's half a millimeter, can project vivid, full-color images and dramatically reduces problems like chromatic aberration, which is that annoying color blurring you sometimes see. Plus, it could make manufacturing simpler and cheaper. That's a huge win. Creating these waveguides on a massive scale is no easy feat. It requires incredibly precise manufacturing. But the industry is making huge strides. For instance, glass manufacturers are cooking up new materials with higher refractive indexes to get those wider fields of view we talked about. Nanotechnology and lithography, the same kind of tech used to make computer chips, are essential. Picture this: Some processes involve dispensing over 1.5 million tiny drops of grading material, each picoliter sized, onto a single 6-inch wafer to create the necessary nanopatterns. Mind-boggling precision. And it's not just about traditional methods. Scientists are even exploring 3D printing with ultra-clear transparent UV resin to create waveguides. This could lower costs and give designers more freedom. Companies like Vuzix are also refining their manufacturing with techniques like micro-touch imprinting, which is gentler on the materials and improves the success rate. And we're seeing strategic partnerships, like between optics giants Jot and Loomis, teaming up to scale production and make these advanced waveguides more accessible for the mass market. So what's the ultimate goal here? It's simple, yet incredibly ambitious. AR glasses that are as comfortable and unnoticeable as your everyday eyeglasses, something you can wear all day long. But there are still a few hurdles to jump. We've talked about reducing bulk and weight. Single-layer waveguides are a big step. Then there's visual performance. We need even higher resolution, better brightness and contrast, especially if you are using them outdoors in bright sunlight, that wider field of view, and we need to zap issues like color blur and distortion. User comfort is also paramount. Ever heard of the vergence accommodation conflict? It's a fancy term for when your eyes get confused, because the virtual objects appear to be at a certain distance, but your eyes are actually focusing on the flat plane of the lens. This can cause fatigue. Researchers are looking into adaptive optics and eye tracking to solve this. And, of course, cost. For AR glasses to be in every home, they need to be affordable. Streamlining manufacturing and finding cheaper materials are key. Finally, power consumption. We need these optical systems and displays to be super efficient so the battery doesn't die after an hour. When we overcome these challenges, the possibilities are almost limitless. Think about consumer electronics. The next generation of smart glasses could seriously be the successor to our smartphones, with AI seamlessly integrated into our view. In the enterprise and industrial world, AR glasses can provide hands-free information, remote assistance for complex repairs, or immersive training for manufacturing and logistics. Imagine a surgeon accessing real-time patient data overlaid directly onto their view during an operation, or medical students learning through incredibly realistic AR simulations. Education and entertainment will also be transformed. AR can offer richer, more interactive learning experiences and completely new kinds of games and entertainment. The market for AR optical waveguides is set to explode, which tells us this tech has a very bright future. As companies like Magic Leap, Microsoft, Vuzix, and Optics keep pushing the boundaries, and as the tech continues to shrink, get clearer, and become more affordable, AR glasses are on track to go from being cool niche gadgets to essential everyday tools, blending our digital and physical worlds in ways we're only just beginning to imagine. So there you have it, a deep dive into the incredible world of waveguide technology, the engine powering the future of augmented reality. From guiding light with nanoscale precision to the dream of all-day wearable AR, it's a field packed with innovation. It's truly amazing to think that these tiny, intricate pieces of glass could fundamentally change how we interact with information and the world around us. That's all for this episode of Fun Facts Online. I hope you found that as fascinating as I did. What AR application are you most excited about? Let us know. Until next time, stay curious.